let's understand about histogram. So histogram is one of the plotting technique through which the gray levels in the images are understood. Means considered what are the gray levels in the image are. It will plot the number of pixels in each gray level against each value of the gray in the entire image. If you are considering there is an image of black and white, okay, so uh, this is an image. So in this image, or I consider, like, okay, take this image. Let me use some pointer. Okay, so if this is an image, if this is an image, so in this entire image, so what is the gray level? This darker parts are gray levels. Okay, so if this is the gray level, this is the gray level of the image, this is the gray level of the image. So it will plot the graph of that particular gray level in the image. Like this it will plot. Okay, so in this image, for example, the number of pixels, see, considering this area, okay, considering this area, so considering this area of this image, considering this area of this image, how much the pixels which are occupying this area, what is the gray level, because it is having the same gray darker shade. So it will take number of pixels of this darker shade here, this darker shade, this darker shade. So whichever is matching with that number of pixels, it calculates an average and it plots the graph of that. So these many pixels, nk pixels, are having a gray level of rk. So this is how the gray levels are uh, calculated in using histogram function. The function is known as histogram function. So using that histogram function, these graphs are plotted. So that is n is the total number of pixels in an image. Okay, so nk is the number of pixels in having the gray level of rk. So that means histogram function is the number of certain number of pixels, say n r pixels, okay, n r pixel, having the gray level, having the gray level of rk, having the gray level r. Okay, so this is how the histogram summary is drawn, which will provide a what are the contrast and brightness intensity, what is the brightness and contrast intensity in the image is understood. So this is what rk is a kth gray level, nk is number of pixels of the rkth gray level, n is number of entire image number of pixels, and k is nothing but the values, that is 0 to n minus 1 gray levels. See, let's understand how it is now using this image. In the darker images, in the darker images, the gray level would come in the towards, gray level would come towards this side, that is in the lower side, lower part of it. Okay, lower part. If more the gray level, this is the darkest picture which is having more gray level. So the it will have the that indications, that is the graph is plotted at the lower level. If the image is having a brighter level, more brighter level, it will be at the higher gray levels. If the image is having an average contrast, then it comes in the middle of the graph. So entire sum 0 to this much of gray level of n number of pixels. So it is an average. This is high value and this is low value. If it is having high contrast, then it's equally distributed, then you get that graph would be coming like this. Okay. So using this graph representation, image can be enhanced as per the requirement. Okay. Then that image normalization can also be done using histogram method. So it gives the fraction of pixels within the image for each value. So normalization is dividing that each value by total number of pixels in the image, which is denoted as a n by n. If there are n by n is a matrix, like, so you know that if you're reading an image, you get n by n matrix, isn't it? So that is what is how many if there is image of 10 rows and 10 pixels, 10 rows and 10 columns, how many pixels will be there? 10 by 10, that is 100 pixels totally. So the product of row and n, mn is nothing but here number of row. Okay, this is row and this is column. Okay, so number of rows and then column. So that is n by n matrix value. This total number of pixels we get into that, you get in an image. So normalization is given by sin function of p of rk, that is in for each gray level of kth pixel with n number of such k gray levels divided by number of pixels in an image. So that entire expressions are given, that is the function of rk is nk divided by mn. So when you plot a graph with nk versus mn, you get that average. See, in this the same level, it has then various gray levels in the image. Where we can normalize it, it is almost the same gray level, almost to the same gray level, isn't it? So this is how the normalization of images using histogram is done. So that intensity of or contrast at a brightness is uniquely distributed in an entire image. So this is what we call normalization. This is very popular tool because this is used for histogram equalization methods to enhance an image or to compress an image for fragmentation of or any segmentation of image. Okay, so what is that image equalization is? It's a technique that makes the histogram of an image as flat as possible. That is, as far as possible means distributing the gray levels uniquely across the image. Uniquely across the image, making the higher darker image to the average gray and less gray image to the upper gray. So bringing it into equalization, higher value bringing it down, lower value bringing it up. So making it as an average transformation is nothing but equalization of histogram. Okay, so this is automatically determined by a transformation functions which produces the new image with uniform histogram, which output is uniformly distributed between 0 and 1 for every pixel. So each pixel it will have an average value and it assigns that value, reassigns that value to the image. Okay, so assume there is an input image to be enhanced for a continuous gray level with r is equal to 0 representing black and r is equal to l minus 1 representing the, that is then highest bright, least, that is darkest value. Okay, then that histogram value r will be lying between 0 and l minus 1. Then that function is certainly lying between 0 and 1. Then inverse transfer those t whatever the new one you get, that satisfies the true condition. So this is what is equalization is. So output of gray value, what we consider is an s of k, the new value, which is nothing but the transferred value of tk, that is r is a new gray value at nkth value, that function which satisfies the condition which is between 0 and L minus 1. So this is what is known as equalization. How it is done through summing up of all the histogram values, and normalization is normalize the value by dividing the total number of pixels. So that is the summing up of all the histogram elements which is having a similar gray values, summing up of all those, then dividing it by total number of pixels in it uniquely. That means that is an average gray you get. So then multiply the value of maximum gray value around it, that is by neighboring pixels is taken. So this is where you get the new pixel value with the gray value which is gradually increased towards the uniform image, real image. Okay, so this is how this equilibrium is calculated. Okay, so this is very simple to implement, as well as automatic transformation is done. Okay, next comes the histogram matching. This method generates the processed image that has like specified histogram. I mean specified gray level in the image. Okay, so which is matching and satisfying to this image gray level. That part is processed. Okay, so that we generally call it as image subtractions, using image subtractions. So that is the difference between the two image pixels, that is histogram pixel value and then actual image original value. That example is given here, that is image subtraction used for medical imaging purpose for called it is called mask mode radiography. Okay, so image is captured using as a mask image, then injecting the contrast material into like injecting contrast material in the sense this is a darker image, right? So convert that into brighter image. All the darker part is converted into brighter image. So subtracting results will give a enhanced image output of g of xy, new image pixel value. Okay, so averaging is nothing but the same image is calculated for sum of all the image pixels, approaching it to the new image value where the noisy levels are maximum reduced. So this operation is this kind of transformations are used for removing the different noisy levels in the images. Okay.